In this video we are going to build a simple part counting system using an NPN inductive proximity sensor and an Arduino. The goal is to understand how the sensor works, how to wire it, and how to read its output, and how it can be used in a practical project. I use an Arduino because it is a very convenient tool for fast prototyping. So we can focus on the sensor and the application instead of low-level configuration. An inductive proximity sensor detects metal objects without physical contact. Inside the sensor, an electromagnetic field is created near the sensing surface. When a metal object enters this field, the sensor detects the change and switches its output. This is NPN sensor, so it has a sinking output. The three main wires are brown for the positive supply voltage, blue for the 0 volts or ground, black for the output signal. Always check the label or datasheet of the exact sensor before connecting it. For the Arduino input, the black output wire is connected to a digital input with a pull up to 5 volts. When no metal is detected, the pull up keeps the input close to 5 volts, so the Arduino reads high. When the metal is detected, the internal NPN transistor pulls the output close to the ground, so the Arduino reads low. So the logic is inverted. No metal means high, metal detected means low. The Arduino ground and the sensor ground must be connected together. Also, never connect 12 or 24 volts directly to an Arduino input. Now we can move to the program. The Arduino continuously reads the sensor input. We do not want to count the same object many times while it remains in front of the sensor. For this reason, the program compares the current sensor state with the previous state. A new part is counted only when the input changes from inactive to active. This is called edge detection. Each valid detection increases the counter, and the new value is sent to the computer through the serial connection. This simple principle can be used to count metal parts on a conveyor, gear teeth, finished products or components entering a machine. In this demonstration, I move metal parts manually through the sensing area. The sensing distance is short, so the position of the object is important. Different metals can also have different effective sensing distances. Instead of using the Arduino Serial Monitor, I use a small Python program with the PySerial library. PySerial allows Python to communicate with the Arduino through the USB serial port. For this experiment, it displays the counter, but later the same program could save data to a file, add timestamps, calculate a production speed, create a graphical interface, or send the data over a network. The process is simple. The sensor detects the metal object, the Arduino reads the input, the Arduino increases the counter, sends the result over USB, and the Python programmer receives and displays. After confirming that the electronic part works, I create a simple holder for the sensor in FreeCAD. The holder keeps the sensor in a fixed position and provides a repeatable sensing distance. After the design is complete, the model is exported, sliced and printed on a 3D printer. At the end of the video, I draw a simplified electrical diagram. The brown wire is connected to the positive sensor supply, the blue wire is connected to ground, the black wire is the NPN output. A pull-up resistor connects the Arduino input to 5 volts, and the same point is connected to the black sensor wire. When the sensor is inactive, the internal transistor is open, so the Arduino input remains at approximately 5 volts and reads high. When metal is detected, the transistor turns on and pulls the input close to 0 volts, so the Arduino reads low. Current then flows from the 5 volt supply through the pull-up resistor into the black output wire through the internal transistor and finally to ground. This is why the NPN sensor is called a sinking output. In this project, we learned how an inductive proximity sensor detects metal, how an NPN output works, how to connect it to an Arduino, how to count each part only once, and how to transfer the result to a Python program. Possible improvements include software filtering, saving the counter with timestamps, adding a graphical interface, measuring production speed, or using two sensors to determine direction. For a real industrial system, electrical isolation, shielding, cable routing, and input protection should also be considered. The main idea to remember is simple. When an NPN proximity sensor is activated, it pulls its output toward ground.